Oh, hello again, Twitch. We're back. We're back for another episode of Howdy Partner, AWS Howdy Partner. I got Mo again. Mo's back. I'm always
This is my
excited.
third.
This is your third one already?
Numero
Really?
tres. Numero tres.
Man, are you serious?
Sir.
Where does the time go, Mo? Where does it go?
What is time, man?
Time is a construct, Mo. We got two friends joining us over that direction. I got to get my directions right. Over there and up there. We've got Anna and Eugene from Gremlin. We're going to hear from them in just a second. But before we do, Mo, you got to tell us, what is Howdy Partner? What have these people stumbled upon?
I forgot. I think it's a show. Some sort of show. We bring on people. I think we bring on friends. We talk about tech and chaos and things and stuff. We have a rootin' tootin' good time, I think. Is that a good description?
I feel like I'm at an IHOP right now or something. That's this rootin' tootin'
Waffle House.
Russian.
Waffle
Is that,
House.
or is it Denny's? Who's over Miami? I don't know. So Howdy Partner is a show.
Denny's get to Miami.
The moon's over Miami, right? That's my favorite thing. I don't actually eat that because I don't eat meat, but like that's my favorite dish to say from Denny's. I think that's the greatest name. Anyway,
That's
so
a Texan doesn't eat meat.
no,
Sorry.
I'm
I'll
a
be
vegan.
quiet.
I'm a vegan. I have to tell you that, like contractually, I'm obligated as a vegan to tell you within the first 5 minutes of being, in the
How do
presence.
you survive smelling all the tasty barbecue from Texas? Like, first thing I do when I land there, I'm like, all right, how do I get to Franklin's barbecue? Thank you.
Yeah,
100%.
it's been a long time. I don't even remember what meat tastes like, to be honest. It's like 16 years, I think. Anyway, before we lose all of our viewers, Howdy Partner.
This is only gonna get more.
Yeah, I mean, this is what the show is, everyone. We're here to have a good time and also teach you about some cool partners in the AWS Partner Network, which is, go ahead, Mo. Go ahead.
Teach who I am.
Everyone, whether you're technical, non-technical, if you're just starting your career, if you've been in your career for 40 years, we really want anyone and everyone to watch, ask questions. That's why, Mo and I are monitoring chat. If you have questions for Anna and Eugene as they go through the wonderful, amazing demos that they've prepared for us today, we'll get those questions surfaced up to them over there, not over here. I keep wanting to point like you're all just like right over here, but you're not. So this episode, we're joined by Gremlin and two very wonderful people. I feel very honored to be able to be on the stream with you two personally. I think Mo does too. We were talking about how excited we were for this one. We actually, if you haven't noticed already, we're wearing the logos, which is
Coolest logo of all time, by far.
Yeah, I think it's one of the greatest logos in tech I've ever
Comes
seen.
in a plush.
Mo's a super fan, just so you know.
Super fan.
Yeah, I had. This is not yours, but I think it's related.
It's the coolest thing ever.
It's from my wife's tiki mug collection from the movie Gremlins, obviously. Which we're gonna have a really controversial question later. I have to ask about the movie Gremlins, if you've ever seen it. I'll give you the question. You can think about it. Is Gremlins a Christmas movie? Think about that. We'll talk about it later. Do you count it as a Christmas movie? I would like to know your opinion as to, what do you, Gremlinites? Like, what do you call yourselves internally?
Grammys?
We do Grammys, we do Grems, we just do Gremlins.
Okay.
High fellow Grems is what we usually say, just to kind of shorthand it for everybody internally when we're trying to ask a question for everyone.
Okay. I like it. So we're going to talk about chaos engineering today, right? This is It's a term that I think a lot of people have probably heard, and even more people don't know what it means. I definitely fall into that camp. What about you, Mo?
Right. No, so usually on the show, at least on the past 2 episodes, I've kind of set the stage for our I guess our guests, right?
Yeah.
But in this case, I think our guests don't need me to set the stage for them. So I'm just going to ask a bunch of questions, learn all about chaos engineering.
Yeah, and just to reiterate, as you're watching, if you have questions, please put them in chat. So I'm an SA here at AWS. We got Mo up there too. He's also an SA at AWS. And we have our two friends. I'm going to do it every time. Our two friends from Gremlin. Anna, do you want to kick us off and tell us a little bit about yourself?
Yes, for sure. In general, I'm very excited to be on today's Twitch stream, not only with Eugene, with AM and Mo. Definitely love working with both of you. A little bit about me. I've been with Gremlin for 2 years. It would actually be my 2-year anniversary at the end of the month. So time is definitely passing by really quick. But I have been with them as a chaos engineer since then. And that basically means that I work with our community, I work with our customers in ways that they can actually implement chaos engineering practices into their groups or organizations. I do talks on chaos engineering. One of the big initiatives that I run at Gremlin is that I also run our workshops. So I've been running interactive workshops for 2 years on fundamentals of chaos engineering, how to do it. Some other things about me, I've been doing chaos engineering for 4 years. I got started when I joined when I joined Uber as a site reliability engineer, and I was placed on the U-Destroy team, which is the chaos engineering tool that they built in-house. And that's kind of like where I started getting my foot into the door with the concept of production, distributed systems, microservices. At that time, when I joined, I think Uber had around 1,000 microservices, and we scaled up to 4,000 in my 2 years there. And apart from that, I've gotten a chance to work mostly on different parts of the stack. So I did front-end development, I did back-end development, and I did Android and iOS applications, all in different types of sectors. I worked at a credit union in Florida, worked at Google, a startup, and I did undergraduate research. So it's all been coming from different little parts of the tech space, but then ending up in systems and being like, wait, I actually never learned this. How do I actually pick it up? But I had the coolest job ever where I was actually able to break stuff and then be like, reverse engineering, this is how everything is working together. And it actually makes my job really sweet now.
It's amazing. Yeah. I feel that like I really relate to that a lot, where like I'll run into something and I'll be like, I feel like I should know this, but I never learned this. And like that's to me some of the stuff that I've kind of learned the most is when I run into something like that, right? When I actually like have to dig into it, and then I never forget it, right? That's really cool. That's awesome. Eugene, tell us about yourself.
Well, dude, that is so impressive. My gosh, where do I begin? Well, so I'm Eugene. I'm a solutions architect here at Gremlin. I've been here for almost 3 years come July. And, I started here being the first person that, really had to try to understand how to work with customers when it comes to chaos engineering, teaching them how to use the product to enable them to build resilience. And it's been a blast over the last 3 years, to be quite honest. But really, I don't think this would have been possible if it weren't for all my life of after high school of doing some level of disaster handling of sorts, right? Started off in the summer of my freshman year, trying to bring back up a data center at my internship place where half of the data center was on fire because they miscalculated the heat thermal envelope of the data center, and half of those nodes just went down. I was like, all right, let's go ahead and change those power supplies. And then I worked at Google for a period of time. We ran some disaster recovery testing exercises there as well. There's a fun story there too about losing $150 million in about half an hour. And then worked over at Netflix as well, helped kind of do some build testing before we release playback systems into the wild. Ran Chaos Gorilla exercises, validated and helped release Chaos Kong as well. and then finally spent some time with all y'all at AWS as well, working as a technical account manager, helping customers release new products, new services into the wild while moving workloads from whatever their environment previously was into the cloud. So all of that really helped build the time that I have to get my time into Gremlin. So really happy to be here, really happy to just share our life experiences.
Yeah, I think it's super cool too. You mentioned at the beginning that, learning how to talk to customers, right, was a big part. That's something that I feel like too is really, really hard to do, and you don't get that many opportunities necessarily to get in front of customers to learn that skill. So I think that's really important. Thanks for sharing that, Eugene. And we always are happy to have an AWS alum on stream too. There's always boomerang too. I'll just say that, there's always the boomerang. You can always come back.
Wow, there's some headhunting going on in this stream too, I see.
I mean, Anna, you're
stream, remember that.
You're welcome as well too. I'm just trying to, influence Eugene because he's ex AWS. So, but
it's a lot easier to be like, come back as a boomerang versus, hey Anna,
exactly.
You want to switch over to Amazon AWS? Yes, go.
That's right. That's right.
Well, I was going to say, this is a great message for chat. Just post a quick short link to your resume right here, and our folks will collect it, apparently.
Yeah, so you all have prepared so much for us. This is going to be a jam-packed stream, I think. But Mo, you're going to kick us off, I think, with some questions, aren't you? You've got some questions for
Just
the
some
team.
questions. Just some questions. You all talked about your exposure to chaos, but a lot of the people watching might have never done chaos engineering before, right? So I guess if you could explain chaos engineering at a bunch of different levels, explain like I'm 5, and then maybe if I'm like a professor, how would you explain chaos engineering?
Is that one for me? Well, chaos engineering. Well, you know what? Let me pass this over to Anna first. I think you give a really great high level of explanation of what chaos engineering is.
Yes. So chaos engineering is the idea that you're preparing for failure. You're preparing for your systems to fail, but rather than waiting until your systems fail at 3 a.m. and you're kind of grumpy getting up from bed like, oh crap, I need to do this, you have actually been preparing for this moment. You've been preparing for moments that matter by running chaos engineering experiments. So it's that idea that that your systems can withstand if one of your nodes goes down, if you have a high load of traffic and your systems need to be auto-scaling, if one of your third-party vendors is possibly having some downtime and you've built in redundancy in the way you built your application to handle such latencies, or the fact that this API calls are just going to be reaching timeouts. Like, how does your application handle such failures?
Do you have anything to add, Eugene?
Really, I think to add on a little bit of that, when it comes to chaos engineering, it's a lot about where you want to shift control of chaos into. Like, we know for a fact that all of the things that can happen, whether you're on-prem, whether you're in the cloud, things can happen, right? Latency spikes, noisy neighbors, a disk failing, stuff like that. It's just going to happen. So the question is just how are you going to handle it? Do you want it to happen exactly as Anna said, at 3 a.m. in the morning, or do you want to take control of that and get on top of that ahead of time so that your customers stay happy, you get more sleep, and you get more time to do the work that you really want to do, versus having 20 person in a war room trying to handle an incident, and all the while nobody's happy, your customers aren't happy, you're not happy, your bosses aren't happy. That chaos engineering tries to resolve that by helping you get ahead of that.
Okay, so who should start chaos engineering? I guess if I'm a lonely developer working on a side project, should I do some chaos engineering? If I'm a small startup, should I do chaos engineering? Or is chaos engineering just something that enterprises do?
You don't have to be lonely, Mo. I'll join your project. You just ask. I'll join.
You're so supportive. You're so supportive.
I mean,
Sorry.
I'll kick us off with that answer. Definitely, it's very much of like, as a developer, you can constantly join a community that can do these experiments with you together. But when we talk about who should be doing chaos engineering, realistically, it's everyone. We believe that organizations that care about reliability of your systems actually should be doing this. But there's also different layers of it. It's like being able to define your downtime, being able to know that your top tier services and applications are actually ready to withstand such failures. And I know that Eugene has also like a larger tangent on this conversation too.
Yeah, I would say that at a high level, beyond just doing technical chaos engineering, right? Like all of us are kind of chaos engineers to begin with. Like if you think about what you see on Amazon.com, you're like, is that gonna fit in my room? Well, let's buy it and find out. It's something like that, and then if it doesn't work, we'll roll back that experiment and ship it back to Amazon, for example, right? So at a retail space, you're a chaos engineer, but when you're thinking about technical stuff, right? I think everybody that has any participation in an application, whether you're an infrastructure engineer, an operator, a site reliability engineer, or a software developer, you all have a responsibility to ship reliable code and as fast as possible, because that's what your bosses want to, right? So everybody should partake in the responsibility of building and deploying reliable systems. So, doing chaos engineering is a great way to start off. Is a great way for everybody to kind of join in on the fun and learning of experimentation.
Got it. Okay. So I got the why, right? There are reasons why. How do I do chaos engineering? I guess. Like, what do I do? Do I just turn off? Do I not use auto-scaling groups and
This is
turn
what
instances
everybody
on and
always
on?
says, right? Everybody
Like,
says
what-
just
what do I
like
do?
turn it off, and see what
Turn
happens.
stuff off? Yeah.
Yes, so definitely don't do that. It's not about just randomly going in and being like, I'm turning off this API, I'm turning off my host. Hey y'all, I'm gonna turn off this entire data center, make sure that you can fail over. That is not how you do chaos engineering. Chaos engineering is a defined discipline. There's science behind it, there's experiments behind it, and there's certain guidelines for it. So you want to go ahead and do this in a thoughtful way. And by thoughtful, we mean actually crafting an experiment. And you want to go ahead and plan this. So this is definitely not about just saying, we're going to start doing chaos engineering experiments on Monday, let's go. It's very much of having a plan, making sure that things are kind of set up. And just to talk a little bit more about the scientific method, the way that it works is that you start by just observing your system. That basically means popping open an architecture diagram, looking how all your services work together. Then you want to go ahead and actually form a hypothesis. What would happen if service A actually just shuts down? Maybe if I'm running in Kubernetes, we actually expect for Kubernetes to deploy it once again and everything's going to work perfectly. Maybe instead we're actually shutting down an entire node, and we hope that we have built it that once one node kicks up, we have another one spin up and we're able to distribute stuff. There's like certain parts of it. And with that hypothesis, there's a lot that comes to it. You'll want to go ahead and define the blast radius and the magnitude of your experiment. That basically means how many hosts or nodes, services are you targeting. And then you want to start off every single experiment in a very small manner. So it's basically that idea of do things slowly to make sure that things go well. You want to start off by maybe just injecting 10 milliseconds of latency, go up to 100 milliseconds of latency. That goes well, then scale that to 150 milliseconds. So it's that idea that you're doing this as a practice. You can't just do chaos engineering for like a week and expect for everything to work perfectly. You actually need to have built enough muscle memory in your organization to do this repeatedly. And we'll talk a lot more into what all that entails. And then of course there's that part where in case your experiment goes perfect, you want to go ahead and scale that up. Your experiment doesn't go well, let's go ahead and actually fix that until you can run that experiment and it runs green. And one of the other things with chaos engineering that like I'm heavily passionate about is very much of sharing your results. So what's all the work that you do without actually being able to like advocate for yourself? So being able to say, hey, our company can actually lose $100,000 of money if we're down for an hour. All the work that I'm putting into this chaos engineering is helping us not have that outage. But at the same time, you're telling your executives, you're telling your management, hey, this is all the experiments that we've done. We've gotten better at creating runbooks. We've actually onboarded everyone to be on call. And there's an extra layer of sharing your results that I like focusing on, where it's like we're all building distributed systems. A lot of us are using the exact same technologies. So once we actually know when a certain technology feels a certain way, why don't we actually talk about it publicly? Last year, I got a chance to talk at KubeCon, and I was actually able to talk about some of the largest outages that we've seen around Kubernetes. And I mean, like you mentioned, auto-scaling. Everyone expects that Kubernetes has this entire abstraction layer that makes your application more resilient, but unless you're actually setting up auto-scaling policies based on HPA, based on CPU, based on network load, you're not taking advantage of some of this resiliency that has been built into the software.
So that brings up a good point, which is like, what are some of the assumptions, I guess, that developers make when building applications that end up leading to catastrophic failure?
Oh man, where do I begin with that kind of a story? This brings a lot back into my days at AWS, where talking to customers, they go, "Well, shouldn't the cloud just do this?" And the answer is yes, when you architect it to a certain extent, right? And that's still that gap that I've been noticing when it comes to talking to either developers or operations side, where they go, "Hey, why is my application not infinitely scalable? We're in the cloud, we're in AWS, we have infinite elasticity, right?" And then operator goes, "Well, we didn't exactly got our auto scaling policy tuned in properly just yet, right?" And so there's like this gap in communications where there's assumptions from the software development side around resources and capacity planning, and operators' assumption around how failures are handled at the application side, right? And so by doing things like game days, for example, where you're failing individual components inside each of your systems, you can then identify, oh, I better kind of dial in my capacity a little bit more accurately or more precisely around even things as low level as IOPS on your disk, right? Or auto scaling group, and how at what level of some capacity of something I should scale up or scale out. That really makes sense. And you can only do that. You can't do that in a vacuum. You're going to have to put some real traffic. You're going to have to potentially put some real traffic and also fail things at a proper cadence in order to realize, hey, at this level, I don't have enough capacity, or this is when things start toppling over, or I better put in some circuit breakers or things at the application side to save me in case infrastructure or platform is going to fail me, right? So like there's assumptions being made and the communications aren't happening, and that's why failures and incidents happen.
Okay. So at AWS, we have this concept of like the well-architected framework, right? And like 5 pillars. They have a bunch of design principles, and they kind of like walk you through how to build a well-architected system. So does Gremlin kind of have any view of that? And does Gremlin does chaos engineering help you with those 5 pillars? Reliability, operational excellence, performance efficiency, cost optimization, security, all those good things.
That's a shameless plug-in for me and AM for the last webinar that we hosted on the Gremlin webinar site, isn't it? Yes. So definitely some direct approach to the reliability and the operational pillars, where one is about, do you test out your self-recovery mechanisms, and do you literally inject faults into your systems to understand how reliable your systems actually are. And some of the questions that you might get during like a well-architected review around the reliability pillar literally ask you to run game days. And if you don't do it, look, you just can't pass the reliability pillar, funny enough. On the operation side, it talks about, do you have the right observability to handle incidents? Do you automate certain deploy processes? Do you have runbooks and playbooks? A lot of times when I see playbooks and runbooks is, yes, we do. Last updated 2015. Great. Like how confident are you in that actually happening now that it's 2020? Like, did your playbook have a lot of procedures put into place. What if your system architecture is completely different already, right? And so directly doing injection and failures and also running fire drills, right? Does your operation team have what it takes at any period of time to understand and detect and triage a particular problem? And so those are the components that doing chaos engineering and injecting faults into your systems will really help train your people, but also make your systems more reliable. Now, for the other ones, there's a little bit of a tertiary point to it, where like cost optimization, for example. We live in a time when everybody wants to cut costs for their infrastructure for one reason or another. Totally understandable. But when you trim too much fat off of your infrastructure at a certain point in time, and I've seen this happen with our customers as well, with our AWS customers, right? When they buy too much compute for any particular reason, they want to trim down. Well, how much are you trimming down of the fat where you're actually getting into the meat? And that's when incidents also happen, right? And so doing chaos engineering, preparing failures, exhausting certain resources on your instance classes really will help you dial down and say, okay, we could trim this much, but any more gives us into a point where we can't react fast enough to scale up or out. And then kind of similarly for performance and other pillars as well.
Got it.
I
Well,
want to jump in real quick, Mo. We had some questions from the chat as well. One on Anna and Eugene. One is from Deacon U or Deacon. I don't know. I always try and say everybody's name, and I always feel like I get it wrong, but it's okay. So this person wanted to know more about chaos engineering at the security group or networking level, which I know you all have some attacks at that level too. So maybe later when we actually get into running some of these things, let's maybe keep that in mind to show if that sounds good. Any comments on attacking at that level from either of you?
I mean, I personally think that from the network level, doing chaos engineering is honestly been one of the easiest ways for some folks to understand it, especially because some of the experiments are pretty visual. And it's also, your applications fail pretty quick if you actually don't build in a magnitude that actually works really well. So we're going to be doing some stuff on the demo side of things that we'll be doing things on the network layer using latency and black holing and packet loss. Yeah, I'm excited about this. Those are some cool attacks. And then Master Mindio, I don't know. I always try.
You try.
I feel so old every time I try and say any of these.
I casted a Street Fighter tournament, my man, so I understand when you can't pronounce people's handles.
Hey, Grandpa.
I think it's Mastermind IO.
I love it. There you go. This yeah. I'm no longer relevant. I get it. It's fine. So this person was asking. This person was asking about do you need to make your chaos services actually fault tolerant, right? Like the chaos injection services. But I think we kind of were chatting to it in the Twitch chat, and I think there's a greater question here lurking under the surface where where does injecting fault tolerance and making sure you have fault tolerance inside services important, right? Do you need it for every single service you deploy? Do you need this level of chaos engineering? And at what level do I, as an individual developer or my team or my company, start looking at testing out fault tolerance and reliability of services, right? How do what kind of things, and I know Anna and Eugene, you both probably have strong opinions on this. What kind of things do I look for before I know, yes, I need to invest the time in building out fault tolerance for this service? I mean, I can kind of start with that question where in the ideal world, we are doing chaos engineering, building in fault tolerance into every single application, but we know that we don't have enough engineers to do that. We don't have enough capacity to be able to think that
we built in fault tolerance into everything. I think it's a nice vision of like we're going to get to a place that everything is actually gracefully degrading. We know that our systems are actually able to withstand a lot of these failures. But I do think that the best way to like start it is that way of looking at what is bringing in money to our business. How are we making sure that those systems that bring in money are actually staying up and running so that our business doesn't suffer any downtime. So sometimes the starting point is like looking at your business and knowing you need to provide value, and money is a value to every business. So just looking at what are the tier services that we need to maintain up and running for the sakes of money, for the sakes of our customers. But then also there's that part where you constantly always want to give your users a great experience. So there's some basic level chaos engineering that you can do to actually make sure that to an extent you're building a fault tolerant experience across your application.
Awesome. All right. Eugene, do you have anything to add?
I'll just add, if you provide a service to other people with your systems, and what you support can go down and create a bad experience, guess what? You should be doing chaos engineering for one reason or another. One is building fault tolerance, absolutely, at the technical level. But again, two is if there are no fallbacks, you're a tier 0 service that, if you go down, somebody has to go in there and start triaging stuff that your team is prepared for. And so you do chaos engineering to prepare your team to handle those type of things too. At my days at Netflix, like playback systems, right? DRM, for example, is absolutely a service that needs to stay up. And there is no fallback to it. And so when you have to digital rights management.
Okay.
Yep. And so no, you're good. Like, see, you should be a streamer, right? You should own a studio too. When those systems go down, people are going to get paged. So you have to test your paging and alerting metrics to make sure that, if you could detect DRM going down quickly, the right person gets paged and the person knows how to bring it back up properly, right? So all that whole stack, that's all about people paging and alerting. You should be doing chaos engineering to test that.
All right. Okay, well, I want to see some chaos engineering experiments, right? So why don't we welcome the new audience, everyone who's just joining. We're here with Gremlin, specifically Anna and Eugene. They're about to jump into some chaos engineering experiments, and super excited to see what this looks like.
We should start off, Anna. Do you want?
So actually, no, let's actually ask the audience. Like, I think we had 2 questions that we wanted to discuss. Like from the previous conversations, I think one of the questions that I always like asking folks, like, what was your training to be on call like? Were you just throwing a pager? Were you actually put on like secondary and then people actually told you what to do so that you can actually be ready in the case that you do get paged in the middle of the night? And with that, we're curious to know, like, have you ever done chaos engineering? What tooling have you used? Is this the first time that you're hearing of chaos engineering? But I do have the follow-up question that will get us kickstarted into our demos too. So now I feel like it's too many questions on the audience.
Oh,
I think those 2 are good. So let's see. I'll keep an eye on chat. You all in Twitch land, share your experiences with being on call. And go ahead.
I know. I was going to say I can actually speak a little bit of my first time on call, and maybe Eugene can actually share his. For me, I have that very sad story that I just got thrown a pager and I was put on call, and I just don't think that was the best thing for myself. That wasn't the best thing for the organization, but I like thinking that in the day and time that we are in, and the jobs that we have as engineers, we can actually build a better world for the next generation of engineers. So actually doing some chaos engineering in terms of like preparing for on call is definitely one of the recipes for success if you've never touched production, if you're onboarding to a new company. And is that idea that you're running the experiments of possible incidents, possible things that can happen while you're on call, but you're also making sure that your runbooks are up to date. You're making sure that the runbooks are actually linking to the right dashboards. Maybe your organization has 3 or 4 monitoring tools and you don't even know where to start looking once you need to start like actually diagnosing a problem, being able to know who is on call for such services. So that's always like a good starting point of like, hey, how can I start off with chaos engineering? Well, maybe we can actually use it to update some of our runbooks, train the next intern that's coming on site, train the next person to be a better incident manager in terms of on-call practices. But Gene, how was your first time you were on call, or even Mo?
I'm good.
You know, funny enough, during none of my times did I ever get official pager until I became a TAM at AWS. All the other ones, I was kind of supporting triage efforts, among other things, right, when it comes to outages that happen. And so by the time an SRE comes to me, like, for example, at Netflix, they're like, we have an outage. We need to reproduce this on this device in this region, for example, right? And so I would be helping with, like, setting up the environment to validate whether fixes are working and to bring a particular service back up. But like I'll say by that point in time, I kind of saw a lot of outages that happened at Netflix. And so when I got put on pager working with customers, I very, very much remember this. I was like, I think it was like 4 or 5 months into me starting at AWS, and I was going to bed, and then the pager happens, and it's like a really critical customer of mine that filed the highest level of severity page. And I looked at it. It goes, all of our outages are all of our services are down. What is going on? And I looked at the time. I was like 12:02. Replied back half asleep. Did your certificate expire? And like next thing you know, they just resolved the ticket. I was like, okay, we're good. Certificate expiring still burns people. I tell you, guaranteed.
ACM. Get that Amazon certificate manager.
All right.
So my next question for the audience is, my next question for the audience was called. Yes, no, I mean it's always that story. It's always that story that I continue hearing. It's like nobody really got put to on call in a pleasant way and in a way that you actually feel like was the right thing. So it's like, let's actually make it better for the next engineer that we bring into our organization to have a better experience, or even if we go to a new organization, let's bring in some better practices with it. But my next question is for the audience so that we can actually decide what to demo for y'all. So we have a few demos that are ready to put into the stove, basically. So would you like to see chaos engineering practices on the infrastructure layer, on the application layer, or on the CI/CD? So choose your own adventure time. So give us 1 for infrastructure, give us a 2 for application, and a 3 for CI/CD.
All right. Let's see. We got an infrastructure. We got a CI/CD. We got number 3. I think that's CI/CD. 2 for CI/CD. Another infrastructure. No one likes the application. No one wants to see Lambda chaos.
All right. Did we start off with infrastructure?
One. Let's start off with infrastructure.
Yep, I think that one.
Game is the winner.
Cool. So give me 1 second to set things up.
Try catch. I think try catch is the just throw exception. That's your chaos engineering. Right?
I think the answer is yes, Anna, as far as what we should be showing.
Yeah, no, I'm getting ready to do this right now. I just need to figure out how to share my screen again. What are computers? I swear I know how to do this.
You're ahead of me.
Yeah, I know.
If Anna doesn't know how to do it.
All right. Do y'all see some socks?
There you go. I put us onto, still see our lovely faces and a screen as well.
Cool. So we have this demo environment that we're going to be using today to actually talk about infrastructure level chaos engineering. But first, before talking about that, let's actually just look at what this application does. This is an application that's been put together by Weaveworks. This is running on Kubernetes. And we have a handy tutorial if you're interested in figuring out how to set something like this up. So we have our front page that allows us to just kind of like browse around. We see that we have some hot socks of this week, and I think the colorful ones at $18 are perfect. So we can just go ahead, add this to my cart. I see that I have one item in my cart. I have my $4.99 shipping and handling, brings the total to $2.99. I can just do proceed to checkout, and it's actually missing payment and shipping information. So I can go ahead, and I think I can do this without showing where I actually live.
Oh.
That's actually my work office, so I'll take it. This is a Gremlin office in San Jose, California, so that's going to be my shipping address. I actually think it won't do it. I have a feeling I do need to log in to this. I'll get the login credentials in just a minute, but you would be able to create an account on the Weaveworks application and be able to add things to the cart. Then we can go over to catalog, continue browsing. So I mentioned that this was a microservice demo application. So this means that every little part of this application is actually in its entire other application behind that's coming together. And I'll look for that architecture diagram in 1 second as well. But the way that this is running is that we have 3 nodes in the back. They're M5 largest running on AWS. All of this has been deployed on US East 1C. And we also have a Bastion host. So I can actually go ahead and just do a connect using EC2 Instance Connect. That allows me to bring up handy dandy console. So instead of being able to show that architecture diagram right now, I'm just going to start off with show you everything that's running on the Kubernetes setting. So we have, on the Amazon side, we have CloudWatch and Fluentd. Then we have Gremlin that has been initialized as well. We have some stuff on the Cube system for our AWS nodes, and the stuff that matters is a little bit lower. More things on the Cube system. Then we see that on the namespace of the sock shop, we have our cart service. Then our cart service is actually pulling in all the information from the database layer. We have a catalog as well, and that actually has another database itself. We have the front-end application that y'all got a chance to see me run through the steady state of it. Then, as well as everything else, is that we have an order application followed by the database for it. We have our payment. We have our queue master, and this is actually running RabbitMQ in the back. And we have our shipping service as well as our user and user DB application. So I think I'm just going to tell Gene to actually just get me the architecture diagram and post it on the chat, because I think it's going to be a little bit hard to look for here. But actually, I'm going to just look up the architecture diagram. I think it would help us. Weaveworks sock shop.
I think AM did us the favor of putting the link to our game day lounge. So I think the architecture is in that article there.
Perfect.
Oh, cool. I didn't even know that. I put that because, yeah, Anna and I built this for reInvent last year, and it's a really great workshop, I think, at least, for really learning about running chaos experiments in Kubernetes cluster, which is harder than you'd think.
Yeah, I mean, I think it's very interesting to see everyone rushing to adopt Kubernetes just because it's more resilient and everything. And as we talk to more customers, as we talk to more folks in the community, they have a lot of questions. They're still feeling a lot of pain points. They're not fully understanding how all these abstraction layers work. So I think even being able to poke around in a safe environment, how Kubernetes works when you have your application is actually just a good value of time. But we see here that this is the front end that I was mentioning. Then we have the order service. We have the payment service, user service, catalog service, cart service. Then I mentioned that a lot of those have their own databases in the back. Then we have shipping and the queue. So that is architecture diagram. So let's actually go ahead and start our first chaos engineering experiment. Just to kick off in terms of timing, why don't I ask y'all, like in terms of this architecture diagram, which application would you like to see some failure be injected in? This is part of our choose your own adventure plans for today.
Yeah, we get to attack whatever we want. Well, not we. Twitch chat.
I'm not a big .NET fan, so I would probably attack that one personally.
If I break the payment system, do I get it for free?
Yes, you get everything for free. And actually, Eugene, would you mind getting me the login for the sock shop? I think it's on the main WeWork site. It's just like admin password, I think is what it was. So I can log in later to make an actual payment.
Let me check.
Getting some votes for the payment system.
All right, payments is going to be it. We're going to start off with payment.
Okay, so hold on there, Anna.
Yeah.
Where are you right now? What is this thing that we're looking at here?
Yeah, so yeah, definitely. I should probably talk about the company that I work for. So Gremlin is a SaaS platform that is able to perform chaos engineering experiments. We're able to support at the node level Linux and as of yesterday Windows as well. We also get to do this on serverless applications, Lambda. We have a application level file injection using Java. And on the infrastructure layer, we also have some support for Kubernetes and for containers. So we'll get to see a little bit more of that after. But from the UI standpoint, it's pretty simple. You can either create a scenario that runs a series of chaos engineering attacks. You can create a new attack. You can see some of your active stuff. You can also schedule some experiments, which Gene's going to talk a little bit about later. And if you have any questions about how anything in Gremlin works, you can just easily go onto our docs. And we talk about how to like install it in different layers. We also get to talk about some of the attacks that we do have. So we've mentioned there's various layers of chaos engineering. On the research layer, we have CPU that generates just more pressure on the CPU resource layer. Same goes with memory in terms of RAM. On the I/O, we're just putting in read and write pressure on I/O. On the disk, we're filling up that disk, and you can actually specify some of the folders that actually entails. Then you can actually inject chaos on the host level or container level. So that means actually shutting down a node, shutting down a container. Then we also have some cool stuff on time travel that allows you to skew the system clock. This is the best way to adjust the daylight time savings or prepare for any adjustment that your system might have in terms of time. Yeah, definitely is. Like, if we can go back in time and actually just show folks that our systems were going to be almost okay for Y2K, that would have done it.
You know what this also breaks, Anna? This used to happen to me constantly with my MacBook. Like generating a JWT token, this, like, if your system time is off, it'll break that. It'll make the token not valid. So that's something that's cool.
We always take for granted this time travel experiment. It's usually like a lot of financial institutions that I hear that they really want to make sure that they're okay with daylight time savings, considering their transactions are really time-based. But like realistically, we should be doing this always. Like our monitoring is possibly going to act up because the time travel kind of like gets skewed, certificates, NTP, like so many little things actually take into account time, and we don't really think about that. But you can also do things in terms of like kill some processes if you actually wanna see what would happen if one of your processes starts having some issues in terms of like memory, you just can't continue running on a host. Then on the network layer, we have black hole that actually just drops all traffic going to that black hole, and every single one of them has actually specific ports that you can target. We have a latency, we have packet loss, DNS. So we're actually gonna go.
Just to chime in here real quick, the next Y2K event is going to be January 19, 2038, which is the end of epoch time. So y'all be ready for that 18 years out from now.
Damn. Good to know. Let's make sure to put that into our calendars and prepare for that possible failure that can happen.
And if you need to look at something, I could switch us back to the other view and take us off your screen if you'd like.
Jim, were you able to get me the admin thing for this site?
Yeah, he dropped it in the Chime chat.
From
I
what
can't
it
use the Chime
said,
chat though.
it looks like it's admin.
Okay.
From what it said. Yep.
So I was like, we can just say it out loud. I really don't mind. Admin. It's definitely not admin.
My.
It's okay. I'll go take a look after. So let's actually run our first experiment. But prior to running our first experiment, we actually went ahead and already deployed Gremlin using daemon set YAML that we have available in that tutorial. So when we head over to clients, we actually get to see that our 3 nodes are on here. We get to see some information about it in terms of like the version of Gremlin that is running. We get to know the exact instance IDs. This allows us for us to be a lot more thoughtful in our experiments. If we're running on different clouds or anything like that, you'll see the tags. So if this one's run, all 3 nodes are on AWS. We also get to see the instance type and the regions, and all this stuff is like really critical for actually tailoring your chaos engineering experiments to be thoughtful and running them in a planned way. So to run the first experiment, we'll head over to attacks. We'll select new attack. And because y'all chose payment, we're gonna head on over to containers and actually target the payment service. So I can just do that. And this actually shows that this is going to target the container that is running payment on the soft shop, which is actually just one of the 61 containers that are running in this entire environment in terms of like this application. So we actually get to see what that blast radius will look like in terms of our nodes. We have 3 nodes, so that's actually just going to be running on one of the nodes. Then when it comes...
What was the blast radius? Sorry.
Yes, this is the blast radius. Blast radius is the idea that you want to start off every single chaos engineering experiment in a very small manner. You want to target one container first versus targeting all 61 containers. And we can actually target one later, or we actually do something to the 61 containers and see what happens. But is that idea that you start off with a small blast radius so that you can actually see the incremental value in your experiments. But with that, when you have that blast radius, one of the main things that we talk about is that you want to have some abort conditions. What is going to cause you to stop this experiment? And because we have a small blast radius, it's able to narrow it down in a better way. But some of the abort conditions are always going to be pretty normal, where if I can't access my application, that's an abort condition. If I start seeing too many 400, 500 errors, that's an abort condition. If my organization has implemented SLAs and SLOs and those get breached, that's an abort condition as well. And when we talk about abort conditions, the reason we mention them a lot is because you want to go ahead and have the idea that if at any moment of your experiment an abort condition is met, you don't want to like think about it twice. You want to just go ahead and press the big red button that halts all experiment. And this basically means, hey, I'm being careful and thoughtful about my experiments. And it doesn't really mean, hey, I failed as an engineer and I didn't scope out my experiment. It's just, hey, the system didn't handle this properly. I'm going to go back, make my system more resilient, and then go ahead and run this experiment again.
Anna, when we're talking about containers and nodes, can you explain what we're attacking in a Kubernetes world? What's the difference between the container and the node?
Yes. So in the Kubernetes world, we basically have an orchestration layer that is going to get all of our applications and tell them in what node to live. So I mentioned that we have 3 nodes on AWS. So we see our 3 nodes that are on there, and then we have Kubernetes that has been would actually be installed and have a chance to orchestrate things that way. But we're actually using the managed Kubernetes service that Amazon provides called EKS. So we actually have a cloud formation for this at the tutorial as well that A&M, Eugene, Mo, and I put a lot of time in last year. So in these 3 nodes, you have those are your hosts that are actually running Kubernetes, they're running your application. And then on top of the nodes, you have Kubernetes that is basically distributing all of our applications that are seen here to actually be living on those nodes. So you're actually then able to like narrow it down, like, hey, my payment service, what node are you actually living in, serving traffic off? But it's also that idea that you hope that in case one of those nodes dies, either all of those services that used to live in that node can now go live into a new node, or a new node gets spun up pretty fast that everything just kind of shuffles in that way.
Cool. Thank you.
No, for sure. Always bring the questions in. I mean, I think Kubernetes, like I mentioned earlier, it's gotten adopted really quick for all the buzzwords, but not everyone has an understanding of how things work. And even myself, I'm constantly finding new little things that Kubernetes can do in terms of like making systems more resilient. I'm like, cool, I can also implement that thing.
Awesome.
So
okay, so let me just introduce everyone again. For everyone who's just joining, we're doing some chaos engineering with Anna and Eugene from Gremlin. And I think Anna just ran a chaos event. But what do we call these? Chaos experiments, right?
Attack.
And just an attack. Okay, so we just ran a chaos experiment or an attack. What was the experiment? What were we trying to find out exactly?
So we haven't run it yet. I'm about to run it. We're in a part of like setting this up, and then we started talking a little bit more about the Kubernetes part. So the way that it's going to be run is that we're going to have a hypothesis that our application is going to be up and running as our chaos engineering experiment is happening. And the abort condition is that if we can't add things to cart or anything like that, we should probably halt the experiment. But prior to that, give me 1 second to actually make sure that I can log in so we can see the full thing. I'm going to stop sharing just for 1 second.
You got it.
No worries. Oh.
Just sharing stopped. Just trying to figure out why I can't log into the demo environment that is pretty vanilla.
That's okay. I can cover for you. This is where I shine. So let me ask you this.
Pride, AM.
Eugene, has it been banned yet at Gremlin to mention Jeff Goldblum? Is that banned? Is that just like you will be immediately fired if you start talking about Jeff Goldblum in Jurassic Park while working at Gremlin?
No, we love Jurassic Park. I will say we have banned a certain movie's theme song that is relative, and the movie's title is similar to our company name. I wanted it to be our lobby's theme, so anybody that comes in just has that menacing tune instilled into their head. It's great for people that want to interview with us because they're like, is this what I'm really stepping into?
So Jeff Goldblum's cool.
Jeff Goldblum is cool.
Spendison 111. He was asking, he or she was asking, or they were asking if this chaos engineering attack that you were setting up in this UI, if it was an AWS service or some other tool. Well, it's Gremlin. It's a AWS partner. That's what they're here to show us. They're here to show us all about chaos engineering.
That's right. While Anna keeps on getting set up, just a little bit more overview about Gremlin and what the service offers. So we're a chaos engineering platform that has the roots of our founders being from Amazon as well. And we built this type of tooling at Amazon, built it also at Netflix as well. And we're just trying to make it available to the rest of the world. As a platform, we feature 11 different types of infrastructure attacks. And, Anna's going to walk you through one or several of these types of attacks on the payment system, and you're going to see what it has effects on for the payment system. But yeah, 11 different failures on the infrastructure side and also application as well. So really, really lots of reach for the types of things that you want to fail on the infrastructure layer.
Are you ready for your screen to come back, Anna?
Yes, we're good now.
Got it.
So in case anyone decides to follow this tutorial at home and you're also wondering what my user accounts for the SockShop app, you can go over to the documentation and you check the user account and you see that the username is user and the password is password. Don't know why I didn't just try that. But hey, this is part of learning. There was no runbook that I could find to figure out how my application works if I actually needed to log in. So we had added one colorful sock. Then we have added already a shipping address that's already been defaulted for us, so we can proceed to checkout. And my orders has actually shown up. We see that it's shipped, and we can view it. We can see the invoice. So this is actually the steady state that I actually wanted to show earlier. So this is perfect. So now we can actually go back into setting up our experiment. We've already decided that we're going to target the payment service. We see what that blast radius is, which is 1 container out of the 61 containers that are running. And then when it comes to running our attack, we have various things that we can do. But I think one of the most interesting ones for today is that we're going to head on over to our networking layer and actually just select latency and inject 120 seconds worth of time for our experiment. Right now, the default for this experiment is that we're injecting 100 milliseconds of latency. So I'm going to go ahead and actually increase that to 150. I feel pretty confident that our application can withstand 100, but I'm not sure if it can actually withstand 150. So we're actually going to leave all of our values as default, but some of the things that you can actually do is that you can actually target what IP addresses to target for the experiment. You can go ahead and whitelist certain things. So we're actually whitelisting API Gremlin for this experiment. You can specify some ports. You can do things on the tag layer if you want to be a little bit more specific. So just to recap, we're going to inject 150 milliseconds of latency into our payment service. My hypothesis for this experiment is that my application can actually withstand 100 milliseconds. So I want to see what the 150 milliseconds of withstanding is going to be like. I think it can do it. I'm pretty confident that I built a resilient application. And that means that my abort condition is going to be that I can't actually add anything to my cart. I see any error pages or my application just completely crashes. Does everyone feel confident with those hypothesis abort conditions?
I think it'll crash.
And burn.
When you send attacks, so it says run the attack right there. It looks like you can you can schedule it for later. Interesting. Okay.
Yeah,
Cool.
scheduling attacks is an entire other topic that I'll let Eugene talk about after. But for this one, we're actually just going to run it now. So I'm going to unleash that gremlin.
If this was bought on Amazon Prime, I'd just get it 2 days and 150 milliseconds later.
So we're going back to our catalog. We see again our colorful socks. I just really like the socks. I'm going to add them to my cart. I have one item in my cart. I want to go ahead and proceed to checkout. Ooh, it looks like the application was able to handle that. I'm going to see what else I can actually add. So we're going to add the Howdy socks. We're also going to add another colorful. I want a Figueroa set of socks. So now we have 3 items in our cart. That is now racking up to $136.98.
Very expensive socks.
But what actually happens if I won't be able to do anything on this part of it. This is a part of the service that we're actually targeting. So realistically, if we try changing our payment, we would actually see some failure, but I can't fill out my application because the demo site just doesn't let you for good reasons. But my payments are actually going through, it seems like. Actually, this one might crash because I just said that it works.
Oh.
One of the things that I can do is that I can just pop over to our network layer and also see if we see anything on here. Yep, I think it actually can't process orders. So we start seeing that these are actually throwing some 400 errors. Was 400 errors one of our work conditions, or no? It's 406.
406.
Is this an abort condition, or we think that this is an okay experience for our customers?
It's not okay for me. If I'm buying $132 socks, if I'm buying the holy socks, I mean, $100 for socks, I'm trying to make you some money, first of all.
I got some socks that I can sell you, Mo, actually.
Oh, yeah?
Plenty. Yeah, if you're willing to pay $100 for socks with holes in them.
So I think that the reason that this is failing is not for a chaos engineering experiment, but more the fact that we're exceeding $100 worth of budget. So let's actually, let me go check on that experiment. Our experiment ended, so actually our application was able to withstand our little 150 seconds of latency. So as I mentioned, we want to always write some observations on our experiment.
And as long as you wore the socks, I'd certainly wear them.
That might be one of the weirdest things that you've ever said to me. But cool, man.
Ever in internet history.
I'll send you a pair, I guess. Wait. Can you guess what brand of socks that I wear?
Gremlin.
No, I'm giving you a hint. I'm giving you a hint. You can't see me,
I'm not
guess.
sure. I'm not really sure.
Snav. Oh wait, you're not mirrored. Fans.
No, I'm not mirrored.
Snav socks. Huh. I can't tell.
I have Van socks.
Nice. Van socks are actually my favorite type of socks, I'm not going to lie.
Oh, me too.
They're both, too, because he wears my socks, apparently.
Yep.
So I actually was just able to see that our application went back to steady state. I went ahead and I processed this last order. I believe that's, actually this one. So we can still see it. It was my 4 colorful sets of socks. And while we were talking, I also went in and I put in a notes and observation. This experiment was successful. We didn't ever have to press halt all attacks. And for notes and observations, I just ended up writing the application let us add more socks into our cart, and it let us place our order. So that is a success.
Very cool.
So we can run another attack for another service. I think folks had provided some other services that they wanted to see some things happen to. Is that correct?
We had a quick question too around pricing. Eugene or Anna, do you want to talk real quick, like what it? I'm pretty sure you all have a free tier, I believe. Do you want to talk through some of that?
Yeah, certainly. Head on over to gremlin.com/howdy-partner. That first link that you see up there, you can sign up for Gremlin free right out of the box to get tested right away to see how we could get integrated into your systems. If you want more, request a demo on our website, and we're more than happy to get our product in your hands.
Would that be you, Eugene? Would you show up if I request a demo?
For you, AM, only if you'll eat meat with me in Austin.
Sorry. I really love the product, but it's not going to happen.
You know what, AM? I'll do a demo for you.
See, I mean, this is why Anna's my favorite. Wait.
I'll make sure to send you some jackfruit barbecue as well, just to make it even a nicer experience.
See, okay. There's no competition here, Eugene. There's nothing. You're out.
There really isn't. There really isn't. Anna just beats me by a long shot.
No, I say no to that at all. So what was another thing that folks wanted to target on the container level? Or maybe we can I'm going to go ahead and do something with a really large blast radius prior to handing over to do the CI/CD part of the experiment.
Yeah.
So what would actually happen if let me actually take that back. maybe not target all containers.
Up.
Let me, because I'm like, that's actually going to target all the cube system stuff that I don't think that should be okay. Let me actually just do.
We're gonna do both, right? We're gonna do the we're gonna up the blast radius now. We're gonna do the CI/CD chaos here in a bit.
Yes.
Yes. All right.
So I'm actually going to target my entire application that is living on the sock shop namespace. We see that 26 of those 61 containers are actually the sock shop. So the rest of the 61 minus 26 containers are actually Cube System, Gremlin, AWS stuff. And if we also would have set up some other monitoring, you can also see that on there. What would happen if we actually just consume CPU on this? And I'm very tempted to just give it 100% of CPU on all my containers, but I'm going to be a little bit nice and bring that 100% to actually just 80. We're going to have that
CPU on fire.
We're actually going to have that same abort conditions that we had in the last experiment. We expect our application to withstand this 80% capacity consumption being added on to all of our containers running on the sock shop, and we expect our application won't suffer any 400s, it won't suffer any 500s. We're still going to be able to see the steady state, but that abort condition, if we need it, we're actually going to go ahead and halt that experiment.
All right.
Unleashing that gremlin.
Unleash the gremlin.
So we have that up pending. Let's wait for the experiment to start running.
DGK Skate Life agrees, by the way, that the merch, the branding, top notch. Top notch.
There it is.
Yeah. Fun fact, if you join our Slack and give us some, share a little bit about yourself on the Slack, we'll send you a sticker sheet. So get on that, get some merch.
Uh-oh. I'm starting to see some weird things where things are not loading up when they should.
Uh-oh.
Analog. So there is a little bit of latency now with our CPU kind of like being ramped up. And mind you, these are M5 largest. So we're not just running on some like AWS free tier service instances. Right. So we add things to the cart and we start seeing that our application is actually slowing down. And we had added things to the cart, but there was a latency for it to actually show up. So let me actually go back and put that latency happening. One of the things that we also mentioned with chaos engineering is that it works with having some monitoring observability in hand. So you can actually go ahead and also just reference some metrics on here. Since we haven't set that up for this experiment, one of the things you can do is just pop open Chrome developer tools and look at the response times of these things. So just out of the box, you actually have some stuff if you're playing around with an application that has a UI. So now we know that on the 80% of capacity, we actually almost seem like it injects a little bit of latency. And then in terms of Kubernetes goes and ways to make Kubernetes more resilient, we actually think that setting up horizontal pod autoscaling can actually help a lot of organizations. I think it was like 25% of the outages that we actually explored last year was due to autoscaling not being set up. So you can set that up, of course, on the HPA layer, but we also say to go above and beyond and actually also set it up on the node level, making sure that you have enough nodes that can actually withstand a traffic spike or anything like that would be helpful. So I could actually demo how to set up that and like how to validate that, but I think I'll give it to you as homework. If you actually go through our tutorial that we have posted the link on Twitch, you can actually see that on the first experiment that we actually tell y'all to run is to validate autoscaling on this exact same demo environment. Then you want to ask yourself some of the questions. Was the service able to withstand the CPU load that was added? And for the scenario that this example kind of gives, you actually see that it doesn't really withstand it very well. So you actually want to set up autoscaling, and then we actually guide you on how to do that by going into AWS autoscaling groups. And when you go on there, you can actually go ahead and set up the CPU to auto scale based on CPU utilization. So we actually put some guidelines on how to make it work out of the box with Gremlin using our recommended scenarios. But we can definitely customize that to be more on the industry standard of like 80% CPU utilization, 75% for it to auto scale on. But then the other thing that we tell you to do is to actually go ahead and rerun the scenario. So now that you had actually set up auto scaling for your environment, you want to go ahead and make sure that you set it up and it actually works. So then you just run this exact experiment again until it's resilient and you make sure that everything's working.
Very cool.
So with that, I'm going to stop sharing my screen and I'll let Eugene do a little bit of the ramble for CI/CD and a lot of the questions that we also may have had.
Mo, are there any questions that we should field before moving forward?
I'm really excited for the Slack though. Let's see. GGK Skate Life joined. Let me see if there are any questions. Yeah, I don't see anything.
Okay, well, if that's the case, let me go ahead and move into doing a little bit of automation work. And to set a little bit of precedence, really want to take some people on a journey around doing an experiment, but moving into say, okay, why do we want to automate? Why do we even care about doing chaos engineering in the pipeline, right? So pardon me for sharing slides for the first time in this whole show, but I'm going to do so anyway.
All right, here we go. I don't know if I should. Oh, yeah, here's a slide.
Oh.
Okay.
This is a slide.
Yeah, there's a question.
Can Gremlin do chaos like on Fargate?
We can. The difference between what we can show you in EKS, for example, versus Fargate is that we can't install our agent into Fargate nodes because it is a managed service and all. But we do have Alfie, which is our application level fault injection, and we could use that for your to inject into your code itself to run things like exceptions and latency. So that's how we can support Fargate integrations and Fargate applications. Cool. All right. So this is a journey that most of our customers and we ourselves at Gremlin and in our previous engagement being chaos engineers usually go on before we even think about automation. And the reason behind that is we want to validate that individually, manually, our systems are going to be resilient and reliable against certain types of failure modes before we roll that type of failure into automation. There's no point in automating something if you know every single time it's going to run, that it's just going to bring your system down. You don't want to be continuously creating an incident because it's fun. Like seriously, I would question my employment status at that point in time.
I always question my employment status, by the way.
Would you like to share why, AM?
Because I'm just waiting for anybody to figure out that I'm a fraud, right? And that I'm an imposter and all those things. That's internally what's happening up in the old Vans cavity up here.
I gotta admit, like this whole full tangent onto something else, right? Like imposter syndrome is something that's really real, even for myself as well. So I feel for you, AM. Like I'm right there with you, right here.
Yeah.
Wait. Could you repeat that? So you're saying, as the director of customer experience at Gremlin, imposter syndrome is real?
Always. Like it keeps me humble, and I think it keeps a lot of us. We want to be humble. We have a very self-critical and introspective culture within Gremlin, and so we kind of always center ourselves around where we are, where we want to be, and then stay humble to that path, right? So that's what I really appreciate.
And I will add on to the imposter syndrome that we're all feeling, because I think imposter syndrome has actually been a huge part of my career, coming from college dropout setting, Latina woman in tech, I've always kind of like felt the eye a little bit larger. But I think it's actually just allowed me to take that opportunity to be like, no, I'm going to be awesome and show you, since there's not that many of us in the field. But there's also that part that I've been able to talk about failure because of chaos engineering, the fact that we can actually embrace failure as a person a lot more, and we're actually able to humanize a lot of our engineering work of like, hey, it's okay if our systems fail in a controlled way, because this is a way that we become better engineers, we build more resilient systems. So I thoroughly really enjoy what I do because I'm able to kind of do a little bit of that.
These are the moments why I do these shows. Like seriously, I really love that what just happened. It started out as me making a self-deprecating joke for my constant anxiety of being found out, turned into an actual sincere moment. Warms my heart. Thank you both for sharing that. It's so important too. Like so many people are afraid to share, I think, legitimately about experiences like this. So yeah.
For sure. So sorry for the tangent. Let me get back into what we were talking about.
Sorry for the tangent. That was an amazing tangent.
You know, the top two portions of this host slide, we're talking about running individual experiments to, you know, implementing a metric for your dashboards, right? Dialing your observability, validating potential fixes to things that might have previously caused an incident. You use those individual experiments to validate whether or not these cases are true. And then game days are those moments where, you know, your app developers as well as your operators can come into the same room, inject failures at the same time, and offer unique perspectives around the application and systems as failures are getting injected, while at the same time testing things like your playbook on how to resolve incidents, how to detect it. Do we have the right metrics? Is the right person getting paged? Like that's all the game days and fire drill portion of things. But when it comes to doing automation, there's these two bottom ones. One is just doing scheduled experiments, right? You put something into a scheduler like a cron job or something along those lines. You could always just continuously fail at a certain interval. But I think the more sophisticated way of doing it is within your CI/CD pipeline. You know, in this world that we live in, when it comes to this agile lifecycle of software development, which is what each of these boxes kind of encapsulate when you're building and deploying code in any kind of company, that you're going to go through version control, you're going to build your code, you're going to test it, release cycle, deploy it, and you're going to learn how to, you know, ship it over to the other side to have it be operated and monitored to some extent, right? And that's where doing things in an automated automated fashion in your pipeline for every single build makes a whole lot of sense. And that's why, like, you know, for here, doing it in a CI/CD pipeline makes it valuable for everybody. Let me go ahead and switch over here to Gremlin. Now, we give you a couple of ways to automate things, and we have a scheduler here that if you really want to just use scheduled experiments, you can. What if all I really want to do is choose all targets and then from here run one host, where I'm just going to shut down and then do it at a scheduled duration for, say, Monday, Tuesday, Wednesday, Thursday, Friday, one time between the hours of 9 o'clock and 5 o'clock. So basically business hours, I'm just going to shut down one host out of the blue, and I'm going to go and put this in my scheduler. Here we go. That's one way of doing scheduler, where my entire ecosystem is just going to have this experimented on continuously. That's one way fashion of automation. But one of the hidden and greatest features about Gremlin is that, you know, everything within our web app, from creating attacks to creating scenarios such as validating your auto scaling, testing for unreliable networks, doing a region evacuation, you can do all of this via our API as well. And so, you know, you could call an attack. You could manage your clients. You can create a schedule. You can run reports. You can save templates. You can run scenarios as well, all in the form of an API. So you don't have to come to our web UI in order to create some of this stuff. But how this ties into your CI/CD pipeline, and I've kind of built a very bare bones type of a CI/CD pipeline where, chances are you're going to go through all of these types of stages, and everybody's CI/CD pipeline is going to be a little bit different because of different types of processes and operations that you put per application. But really focus on just this chaos engineering test portion of it where, okay, this build is ready to get pushed into prod. I want to make sure that in prod, this particular scenario is going to get implemented into this build for as long as this build lives in production, right? So let's take a look at how easy that is. I'm not going to tell you how to deploy Gremlin. I think there's a number of ways to do so. You can use System Manager, for example, to do it. You could put it directly as yet a pre-stage to deploy Gremlin. Really is as easy as, kubectl deploy or something along those lines if you use Kubernetes, for example. But really, it's just copying our our API with enough common delimiters and implementing our API key to say, hey, I'm going to run a CPU attack for all of my hosts in this build for Monday, Tuesday, Wednesday, Thursday, Friday between 9 to 5, and I'm going to consume 50% CPU at any given point in time. And I want to run this 10 times a day. Now let's go ahead and build this. So you wait for however long it takes, get this. Now within my scheduler, you will see that, hey, I just implemented this right into Gremlin for this build that I'm going to run. And it's going to persist for as long as this build stays alive in my production environment. And this is just a way of reaffirming that, if the assertion in this build is, hey, I am currently resilient and reliable against this particular failure mode, I should always be ensuring myself and asserting this fact that it's true for as long as this build is going to persist in my environment. So really, it's just kind of automating this work for you so that you don't have to go back and run another experiment all the time manually. You could do this for any other type of thing. You could use code deploy, code pipeline, whatever it is.
Cool.
All right, I will unshare my screen. No more slides for the time being.
Well, we got a quick question actually. So Rock and _1 asks, how do you consume the feedback from this stage and improve the chaos process when you have scheduled chaos?
Yeah, so prior to any chaos engineer experiment, we usually recommend you to have some level of monitoring and observability tied to your application. So, if you're a very request-heavy type of application that receives a lot of traffic, chances are you're going to have a dashboard or a metric that monitors that, like request per seconds, for example, being very basic, right? You want to make sure that gets tied in to your pipeline to use as a monitoring metric to feed and close the loop of, as we're injecting failure, is this KPI, is this metric still sustained as I'm running this test? And if it is, go ahead, promote it to production, use that as something that's good for you. That way you know that, hey, right now I'm reliable against it. I can now promote this build.
And I think one of the main parts for CI/CD chaos engineering and the purpose for it is that you don't want to be drifting into failure as you build more things into your application. So it's kind of like that idea that as an engineer, you basically, one of like the things that you're scared of the most is regressing in code coverage, regressing in just your application working. So you want to use it as a way to, I actually just added 100 lines of code and my application still works, or even up to the part where like I just refactor my code base and I deleted 1,000 lines. And as I run my chaos engineering experiments, I'm actually able to see that I'm still withstanding the same failures I was earlier too.
It sounds like it's just like all about as little surprises as possible, right? Like you don't really want to discover these surprises at the wrong time. You want to get them at all points during, build, testing, and deployment, if possible. Is that fair?
Yeah, you want to be ready for those moments to matter. The less humans needing to do stuff when they're on call, the better for the engineering culture, the better for the organization. So it's just trying to learn in a way that you're ready to take action versus waiting for it to happen and you just kind of like scrambling to figure out what to do later.
We had another question from Rocket One. Do you store these metrics for later analysis? I think this is actually, and you know, the more and more I work with you all, the more and more I see how chaos engineering and actually measuring, it's inseparable, right? You can't really perform that great of experiments if you don't have the measuring. Sorry, Mo got me with his
Sorry.
flush.
I'm sorry, I got you.
I'm easily distracted, man. You're not learning that about me at all. But yeah, I think metrics, right? And there's a lot of options in AWS if you're deploying in AWS for capturing metrics. CloudWatch is a huge, massive thing that you could probably spend 6 months on and not learn everything about. But
Any
we
monitoring service, really.
Yeah, exactly.
You could build a career out of building monitoring tools.
Yeah. Kibana and Elasticsearch is another like 6 months down the drain that you just went down that hole. Yeah, but for example, Anna, Eugene, Mo, and I, when we were building the reInvent game day, we were taking advantage of a CloudWatch service. You might have seen that in the containers that got deployed, called Container Insights, which gives you metrics down to the container level. So a lot of CloudWatch stuff is built into EC2 instances. You can get more custom metrics too. But yeah, maybe would you two mind talking about more what kind of metrics should I be caring about?
So just to, I guess, like start off that conversation, I'll say that a lot of this comes with the maturity of your chaos engineering and where you're running chaos engineering experiments. So there's that part where you can't wait until your monitoring observability tooling to be perfect prior to doing chaos engineering experiments. Because waiting for that perfect world, you actually might be a year or 2 years far away. So waiting for that is just going to slow you down and actually building more resilient systems. So you want to think about like, all right, maybe I want to focus in doing just some research level chaos engineering first and make sure that I get some baseline metrics in terms of CPU, disk, IO, memory, and just focus on doing those experiments, and then eventually graduate and have a better chaos maturity to run more experiments on the state network layer. But I think as you run chaos engineering experiments, you end up finding out of like, oh man, like my dashboard is not tracking my response rate. I should actually just be tracking my like SLO on here too. Or I need better debugging, I need better observability. So you're actually starting to uncover a lot more things that can help your organization be successful, be more resilient in the process of doing this. So like putting it off is not a thing that you can actually afford.
Yeah, I'll tell you, when it comes to observability and monitoring, many of our customers, it's their first time running failures into their systems on their terms, right? And so, a lot of times they would come and say, "Hey, are you sure you're running up our CPU?" And I go, "Guaranteed. At worst, you SSH into your box and run top," right? For example, as basic as that sounds, run top. And they go, "Oh, there it is. Why isn't it in my dashboard?" Because you might not have that metric dialed into your dashboard. And so really doing chaos engineering is like, it's building up that dashboard, especially if you have a new workload in a new platform and you're starting from scratch, right? Chances are your dashboard is really, really immature. And so it's not so much that you need very, very sophisticated tooling to begin chaos engineering, but chaos engineering and failure injection generates those signals that you need to say, hey, I'm not detecting this. I need to detect this right now. I better put in this metric in some way, shape, or form. And that's just at the infrastructure level, right? The closer we get to your business level metric, the more important, the more insight that you're going to be able to get and at a higher fidelity. For example, at Netflix, because our infrastructure was huge, right? I mean, playback systems, thousands of instances, API, thousands of instances, Cassandra, tens of thousands of instances. So Netflix gives you guys a lot of money, guys. But we have no time to look at every single host metric as far as how much disk space is being used or how much CPU is being utilized or even how many RPSs are there. And so we had a top level business metric that we use as our guiding North Star to say, is an incident happening? Are we failing? We called it streams per second. How many people are streaming? How many our licenses are getting issued at any given period of time? In this case, 1 second. And we would capture those traffic trends across time, and we called it week over 2 week metrics, right? To say, hey, in a steady state and as a growing business, we could assume X number of percent growth because we're growing that many subscribers over 2 weeks. And then we just see this trend line of SPS kind of have this nice little cycle. I guess now now that Netflix is global, it should just be a flat line the entire way through. But that's kind of what you use. Amazon, orders per minute. Google, ads per millisecond. Everybody has a top level type of service metric. Kafka, how much throughput are we getting through even your pipeline, for example, right? All of those are like top level business metrics, if you will, to help you kind of detect whether an incident is happening or not.
Very cool. So
see that question from Daily Disclosure, Mo?
no, I didn't.
Okay.
Do you think smaller engineering teams at growing organizations can benefit from chaos engineering? Or is there a stage when you think teams should consider implementing chaos? So actually, I think I kind of asked that question towards the beginning, if you weren't here, Daily Disclosure.
Yeah.
But yeah, Eugene, Anna, do you all want to answer that?
I think it's you sums it up in a bigger way.
Yeah, I think it's cheaper when you start out small. We at Gremlin, we have startups as customers, and we have huge companies that are with us as well, like Fortune 100 companies that are with us. And what has been very, very obvious to me is the less complex your systems are, the easier it is for you and your small team to get used to chaos engineering and to have that mindset and culture embedded in you, such that as you scale, you think of reliability as a first-class citizen, as a very important metric to have. And in some ways, it's also a differentiator for you where you could actually reliably ship code faster as well, because you have chaos engineering here to catch you when you fall, right? Versus like, okay, I'm a 50-year-old company with a lot of history, with a lot of legacy systems. I want to begin chaos engineering. It's like, cool. Where do we begin when you have tens of thousands of hosts right there to begin with, right? And tens of thousands of services as well. So it's more expensive and it's harder when you're actually a lot bigger. So I would encourage you, if you can, start as early as possible. But if you're already at scale company, choose ideally the most important application that's within your control and begin there.
Yeah, I think Eugene nailed that answer. It's like the earlier you start, the better. It's also like if you're a startup, this can actually make you stand out from your competitors. You're actually being able to withstand if you have a traffic spike. If your application was to be something that could have helped folks right now and have more, being able to like handle more high traffic, that actually might be able to like withstand, like might be able to help you stand out from your competitors. And that is such an amazing story to be able to say, like, we actually thought that we were going to have a lot of traffic, that we were going to become a larger organization, but even though we were an engineering team of 3, we made sure to put resiliency in the top product values, and we have now created a business like as you go on. So I think if you leave it till the end when you're like a global company, it's a lot harder to be like, oh man, how do I get everyone to start thinking about always being up and running, having 4 or 5 nines of reliability as a vision. So it's like the earlier that you're able to have those conversations with your founders, your executive team, your board, the better is going to help, because after you have possibly scaled to 100, 1,000 microservices, you're now going to have to do a lot more cleaning. You're going to have to do more onboarding of every single engineer to actually be able to think about your systems in a resilient manner.
I mean, I know I'm not an official Gremlin, a Grim. I forget. I like to think maybe I'm honorary. I don't know, but I think that point around startups, Anna, is so brilliant, right? Because like a startup should be operating like they're one Shark Tank episode away from exploding, right? Like that's, and if you're not ready for that, your product may only get that one chance, right? Like that's it. And if you can't stand up to that, you may die in obscurity because you couldn't meet the demand. So I never even thought about that. That's such a cool point.
I think it's one of the architecture questions that they used to ask at Uber that was like, what do you do for your URL shortener in the case that this gets put on Twitter and all of a sudden it just kind of like blows up and now you need to scale this to be able to sustain thousands of customers concurrently and like all these things. But it's that idea, if you actually are able to implement that from the beginning of like, this is our plans to scale, this is our way of like setting up runbooks. And it's just, it can start off in a very manual way and gradually you can build that maturity as we mentioned earlier too.
I love it. That's so cool. Awesome. So I saw earlier DKG Skate Life had asked around what are some upcoming features for Gremlin? What are some things? I think that leads me into two different areas that we could talk about. I know there's another portion that we haven't seen that you had mentioned earlier, Anna, around Alfie and application level chaos. I don't know if we're gonna go into that or not. It's totally up to you all. And then two, maybe Eugene and Anna, you could give your most excited thing that you can publicly discuss that Gremlin will be added. The thing you're most excited about.
I also, in the comments, I posted the, you all have a public product roadmap, I believe. So I posted that link in the chat as well.
Yes. So I'm actually just going to go ahead and do that Alfie demo
Yeah.
link. I'm like, how do I screen share again? I know I did this earlier and I said the exact same thing. So let me actually just maybe start off. I'll start off with the way that Alfie works. So we have Alfie as a Java library right now. We're looking at supporting more later on. But basically, we're able to run chaos engineering experiments on Lambda functions, so covering serverless, and anything on the application level that is running Java, you're actually able to implement our libraries on with it. And then what you actually do is that you set up some traffic coordinates, and that's actually what allows you to be specific about where to run such chaos engineering experiments. And the same way that we talked about experiments on the Alfie layer, the one thing that you can do is that you can do outbound HTTP traffic. So this allows you to actually just target different like verbs, as in like you can do any verb actually, or you can be like, I actually want to get my post and get requests, and that's like the only thing that I actually want to specifically target using Alfie. Then on the DynamoDB layer, you can actually be able to like give it a name and write more stuff in terms of like DynamoDB specifics of operations. But the one that I'm going to show you in a demo later on is actually going to be on the custom traffic type. So in the case that you're not actually using some of the DynamoDB stuff or just wanting to do something on HTTP traffic, you can just do custom traffic type. And then on the choosing a Gremlin, on the infrastructure level, we have a various set of tools of Gremlins that you can unleash. On this one, you can actually just inject latency the same way in milliseconds, or you can just throw exceptions. So we're going to be going ahead and posting the entire code repo on the Twitch chat as well. But just to walk you all into the way that this was done, we actually went in, we created a function. It's called Howdy. Shout out to our awesome solutions architect, Mark Franklin, for building this out for us that I can actually just replicate this. We've actually uploaded the entire Java file, the jar file that is this application. is running on Java 8, and I've given it my handler, which is COM, Alfie Lambda, Alfie demo handler, and we're targeting the handle request. The way that we have this set up is that you actually need to pass some environment variables in order for Alfie to run. With Lambda, we're actually able to just give those up front that make it pretty easy for us. So we've gone ahead and enabled Alfie. We've also given it a name of Howdy. We've dropped in our team certificate of files, which had some specific needs. We've also given the Gremlin team ID that can easily be found as after you create a Gremlin account. And then we also use the private key or file. So this is actually running, and prior to injecting chaos, this should give us a 200 green. Okay, my watch is not going to work knowing my luck.
This is where I complain about cold start.
Yeah. That's the reason I've played around with it a few times. And we see
like
that
Westworld for me, Eugene, when you say the word cold start, doesn't sound like anything to me. Doesn't even register for me anymore.
you're just like, oh, that's normal, right? So we're able to see that this very short Lambda actually executed. In terms of what that actually does, we have the code up here for Alfie demo handler. So as I mentioned, we are actually importing the Gremlin libraries, and this is actually just going to import the AWS application coordinates resolver. We've gone ahead and actually started a basic Java application that allows us to start the Gremlin service factory, and this allows us to pass the Gremlin coordinates. Then we're able to infer things from the environment. This initializes it, and then when we get on here with traffic coordinates, this is the part that we actually give it. We're going to use this coordinates of method and handle request to actually target this specific application in terms of Lambda. So when we head on over to Gremlin, not just this, I'm actually going to be a little bit lazy and rerun the experiment that I had already set up. So my application, like this is actually going to pull up the experiments that I was running on this Lambda just to make sure that we have all the variables correctly. You want to go ahead and select AWS Lambda function. We've gone ahead and giving it the region that this Lambda is working on. And just to verify, it's US West 2. Earlier, I had issues running it because I kept giving it the wrong region. So please make sure this is the first thing you do. Then you want to give it the name of the Lambda, which in this case is Howdy-Anna. I've typed that in. If you have any other custom values, you can actually put that on there. Then as I mentioned, we're going to use custom traffic type. So the name for this is actually Alfie demo handler. And for this, the method and the value for like key in here, we've actually set that up as with field method handle request. So just to show y'all what you would do in order to make sure that you're targeting that is that you put in the key of method, and then handle request is going to be your value. And this is that idea also that you're actually able to be very specific on your chaos engineering experiments. For this one, we're not actually going to be throwing any latency or anything like that. We actually just want to throw an exception for the sakes of the demo. And we actually want to run this right now. This experiment is going to last 60 seconds. So we've gone ahead and unleashed it. We see that this is pending. Just do a quick refresh. I'm now just going to do a split of my windows so we can see this better. And hopefully I can rerun it again.
That's it.
So this actually is the exception, and you can actually see that Alfie tells you that it actually impacted something. So it actually found my Howdy-Anna Lambda function, and we were actually able to throw that exception. One of the other things that we've also done with Alfie is that you can inject some failure at runtime. So I went ahead and I built a tutorial around that I'll drop into the chat shortly after. And this is that idea that in your applications as you're building them out, you want to go ahead and be very specific. So when Alfie got released, the use case that our CEO presented this with was actually like, how do you replicate an outage that actually only targeted your Android devices, but not your iOS devices? So by leveraging something as application level fault injection, you're able to pass some coordinates that say only inject failure if your device is Android, or in the other case, if your device is iOS. So this is like a very much more mature level of chaos engineering experiments when we see folks actually bringing in chaos engineering to the practice, because you actually need to put this into your code base and stuff. And one of the things that I will note is that the way that this is actually running, as we saw earlier, this is just one entire Java file that is setting up Gremlin and is setting up our code functions. But one of the best practices with Lambda is that you should actually be doing things on the layers portion, which I did not know. I just recently learned that, since not a serverless pro. But you can actually abstract the Gremlin chaos engineering part with Alfie and put that into the layers. I don't know if AM wants to share a little bit more on best practices for layers for that portion.
Yeah, AM. What's a Lambda layer? What is that?
Lambda layer. Lambda layer is super cool, actually. It came about at the same time as the bring your own runtime for Lambda, which I think was maybe last year's reInvent, or all the reInvents blend together for me now. But it was at a reInvent that these two features were launched, and they're kind of related. The layers specifically allows you to package up either libraries. So let's say that example I always hear is like pandas or matplotlib, like these ML Python libraries that you need to run like machine learning stuff. You package all that up into a layer so that you don't actually have to load all the libraries together, right? So, for example, when you're building a regular Lambda, right, you have to package everything that Lambda needs to run, all libraries, everything, into a zip and upload it. But with a layer, you can separate the libraries that your code is actually depending on and just upload that and then reuse that layer, right, across all of your Lambdas if you need to. So you can actually make a Gremlin layer, right, so that if you have a like hundreds of Lambda functions that you want to use Gremlin within, you can just reference that same layer in every single function instead of having to individually package all of your function code up.
That's awesome. I'm actually very tempted to go play around with that and just have a Lambda layer of chaos injection. Yeah,
it's super cool. Lambda layers. It's a little hard to get started with, I'd say. I think there's some really good tutorials out there on how to package up a Lambda layer, but yeah, it's super useful.
Very cool.
Alfie is super cool too, actually. I had never seen Alfie in practice. I've only read about it, so it was really cool to see that, Anna. Thank you.
Yeah, I'm gonna go ahead and also drop in that other tutorial that we mentioned for it. I think we've been posting the GitHub repo to actually get started with that code base, but we have another tutorial for this, which is the Hello World of Chaos Engineering and injecting a little bit of chaos at runtime. I am, of course, biased because I actually wrote this tutorial. But it actually guides you into like how to set up Alfie in a way that it uses environment variables. You're using Gradle to import Alfie, and you're also using Spring Initializer to set up your experiments. So it has some of the getting started with Java conversations on there, and there's a repo for it also available on GitHub.
I feel like, Mo, you've just got a bag full of Gremlin merch hidden under your desk or something that you just keep pulling more and more stuff out of. I'm wondering when you'll be exhausted, like when you'll have exhausted all of your merch.
Oh yeah.
You just weren't at our booth at the Game Day Lounge at reInvent AM. We had so much.
Mo's just flexing on us all, like, I think that's what it's really.
I got stickers, multiple stickers.
Oh wow!
Just made it rain.
Make it rain. Gremlin stickers. Yep.
Uh,
I got this little plushie. I got this shirt. What else do I need? I don't need anything else in life. Just like in general, I have everything.
I wanted to
Alright.
circle back real quick to that question that came up from I think it was DKG Skate Life, or DGK Skate Life. Sorry. I think it was What Anna? We'll start with what feature or thing that is public knowledge. Obviously, I don't want you to get in trouble by sharing anything private. What upcoming feature are you most excited about for Gremlin?
I actually went back to our product board to make sure that it's under there. So, we're actually one of the main things that like Gremlin has been focusing on the last few months is something called status check, is being able to make sure that your environment is healthy prior to an experiment. So this actually just kind of helps you know, instead of like verifying the steady state of your application, you build this into the status check. So you actually don't have to go check that, and it takes away that little bit of that extra manual. Of course, you should go ahead and do it regardless to make sure everything's up and running. But I think this makes it easier for companies to continue adopting chaos engineering in their CI/CD pipelines, is that idea of verification and closing the DevOps cycle, closing the chaos engineering feedback loop. So for me, that's the one that I'm really, really stoked to see us launch. What about you, Eugene?
I am a big fan of Alfie. Not the witch, not for any reason, but I kind of helped with our co-founder Colton while we were at Netflix to build up this next little device data center where their folks are running chaos engineering experiments at the application layer. We called it FIT at Netflix, across a number of different types of applications and devices, right? Like Roku's, PlayStation, stuff like that. So I am really excited about getting Alfie into the hands of more developers. And so on the roadmap, we have a number of client libraries that we'll be releasing in the future. Really just quickly want to survey the rest of the group in chat. Like, what do you guys code in? What do y'all code in? Is it, because right now we only have Java. I'd love to see what makes sense for everybody else. Python, Go, Fortran, COBOL. I think New Jersey could use a Alfie COBOL agent right about now. But yeah, Node, exactly. Yeah, so that's going to come for sure.
And C Sharp.
Okay,
The
well,
room goes
there we
silent.
go. Right, it's like I think we're at time. But yeah, I'm really excited about it. I think this is going to be a really great way for developers to not have to worry about the infrastructure types of failures, but more think failures that can happen a little bit closer to their realm of the world too, right? So this is going to be trying to really fill out the software development lifecycle and fit in chaos engineering for everybody.
Yeah, definitely Go and Node.js for me on that. I think I hated Java when I went to college, and I was just like, come on, Java, like I only want to learn you so I can build Android applications. So if I can go back to some JavaScript and or Go, I'll be a very happy camper for the next demos.
This is really important. Basically, everything I say is really important. I'm just kidding. But this really is. This is very serious. I asked you a question earlier about the movie Gremlins. And I hope you've been thinking about it this whole time. One, have you seen Gremlins? Have you watched the movie Gremlins?
Fan favorite since I was 4.
Okay, wonderful. All right.
So I will actually say that I wasn't one of the people that had watched this prior to joining Gremlin, but because Gremlin is remote first, maybe like a year ago, we actually took this upon as an activity. We streamed Gremlins on Zoom, and we had a dedicated Slack channel that we would actually all be chatting like if we were watching the movie together, which was great in so many layers of it. But that was the first time I ever watched Gremlins.
I love this so much. That's amazing. But to my question that I asked earlier, for anyone who joined since then, do you consider Gremlins to be a Christmas movie? Do you watch it at Christmas time?
I do. It's right next to me with It's a Wonderful Life.
I am in to say that this is a movie for all year round.
Oh, even better. I like that answer a lot.
just like It's a Wonderful Life.
I love it. I love it. Mo, I don't know. I don't feel like it's my information to share, but I'm going to anyway. You haven't seen the movie, have you? No.
Haven't even
Okay.
seen Die Hard. I'm behind on all of my Christmas movies.
I know. We just got you watching Star Wars, so we'll work,
Yeah,
work
that
up.
only happened a few. Yeah,
We'll work up to it. It's fun. It's okay.
I'll get that.
Cool. So, like I said, that was a really, really important question. All the questions I asked are always really important. Sorry for derailing everything. Yeah, Mo, do you want to? Do you have any more questions for Anna or Eugene? Do you want to start wrapping things up? We do have the question of our sign-off greeting, which I think.
I think that's the most important question. How do you all want to tell the audience bye? You have two options. Giddy up.
Yeah.
Or y'all come back now. Pick one. And let's release all of these future gremlins so they can go learn more about Gremlin.
Why have I literally just blanked on them? Giddy up, y'all. Come back next time.
Joining them together. I like that.
There you go.
That's perfect.
What about you, Eugene?
Yeah. What do you think, Eugene?
I was gonna use the Die Hard reference because that is also a Christmas movie, but I won't. But yeah, giddy up, y'all!
Oh,
So
Did that sound Texan? I don't know.
that
You
was
tell
very
me.
authentic. That was super authentic.
as Texan as you could get there.
Yeah. So, Anna, any parting words for our audience about Gremlin? Anything that they should somebody brand new to Gremlin, what would you tell them?
I would tell you to go ahead and go sign up for our free tier. We have a really easy to use UI that gets you kickstarted. And one of the things that we're doing with Gremlin Free is that we actually spin up 2 hosts for you that you actually are able to run awesome chaos engineering experiments on. So if you don't have your own AWS account, if you don't want to spin up new AWS instances, you can actually just run some chaos engineering experiments for an hour or 2 before we shut it away. And then go sign up for the AWS free tier and go install Gremlin onto those nodes and unleash some chaos. And always reach out to us. That's my parting words. What about Eugene?
Gene, what's up? Wherever you are.
I'm somewhere around here.
Wherever
Yeah,
in this
go
area.
break things on purpose. Not so much for you to actually break things, but reveal those weaknesses in time. This world needs more reliability in all the systems, especially in this current climate of things.
Mo?
All of the links, all of that is just the tip of the iceberg, right? I linked videos from FailoverConf, so much stuff to learn about chaos engineering, so much Gremlin love, and yeah, giddy up for me.
Giddy up. Okay, so if you're new here, please go ahead and follow. We are doing episodes of Howdy Partner with a different partner every Monday and Wednesday, 2 p.m. Pacific. Next Monday is a holiday in the US, so we won't be here. But you can join us for some Kubernetes fun on the following Wednesday, 2 p.m. Pacific, with our friends at Rancher. So come out and see them. Additionally, tomorrow on Twitch.
What's tomorrow?
Tomorrow on Twitch, nothing with Howdy Partner, but there is a serverless first functions event. I'm not sure on the time.
You mean tomorrow on Twitch?
Yes.
Almost all day, we'll be talking about serverless.
Yeah, it's like all serverless stuff. 8 a.m. to 12 Pacific time. Cookie Points had our back there.
And it's just tomorrow?
I think there's another one of these too coming up on the 28th. I think. I'm the 28th. If you watch,
I'm gonna stop leading you. Yeah.
If you watch on the 28th, you might get a little Howdy Partner surprise. I don't know. Maybe. I don't know.
Maybe.
We'll have to see.
Serverless first tomorrow. Tomorrow's for the org, right? Tomorrow's for the org, and the one next week is like super hands-on, super devy. So
Yes.
please come through to that. Yeah.
And I cannot thank Eugene and Anna more. I mean, you all are incredible. I am both of your biggest fan. I think Mo might fight me for that actually, but we loved having you on. Thank you so much for everything.
Ian, just
Thank you for having us. Thank you so much for having us. This has been a blast. Great audience.
We will have
Thank you for having
to.
us. Thanks for all the audience questions.
Totally. All right. So giddy up, y'all. Come back now. You hear. We'll see you next time. Next Wednesday, 2 p.m. Be there.
Bye, y'all.